Hi, now it's time to understand how we can build our own library of functions so that we can distribute our functions and they can be used from some other programs. In this example, we have a client program that is going to utilize the library ultimately. I'm going to show you this client program later on. First of all, let us concentrate on these two folders. All of this stuff are actually in this particular folder, c_test. Okay. Utils folder contains two source files, area.c and mymath.c. Each of them contains some function definitions. Area.c, as you can see, I'm just opening it. It contains two function definitions. One is get circle area. It's calculating the area of the circle on receiving the radius and returning the area to the caller. And the get triangle area, it's receiving the base and the height of the triangle and returning the area. These are the source codes, the function definitions of two functions. And mymath.c is also containing another function definition, that is this our very own get simple interest. This is going to calculate the simple interest on receiving principal rate and time, and it's going to return the simple interest back to the caller. Okay, these are the two source files containing some function definition. Now get back to the parent. Here we have a directory named headers where I have kept the header files corresponding to each of these source file. The functions that we have defined in area.c have their declarations here in area.h. Let me show you that. Here you can see that these are the two function declarations that are contained in area.c. Get circle area, get triangle area. And this macro tells the compiler not to include area.h if it has already been included by the compiler for this particular programming. That means this is some sort of mechanism that's going to avoid multiple inclusion of same header. Now #if and def, this is a macro command that's going to instruct the compiler to check whether this area_h name has already been included by the compiler or not, already been defined within the compiler or not. If not been encountered earlier, then it is not defined. So in that case, we are asking to define this name, and then within that we are just declaring the functions. So it's going to actually avoid multiple inclusion of the same header. Okay, so this is the header corresponding to the area.c. Now there is another header, mymath.h, that corresponds to the functions declaration that we have in mymath.c file. So there was only one function, get simple interest, so this is the declaration for that, and this is as usually for avoiding the multiple inclusion. So we have two source codes, .c files, area.c, mymath.c, and headers here, area.h, mymath.h. First of all, what we need to do is to build the library for these two source files. And for that, we are just going to the terminal. Just open up your terminal and move to the folder where we have kept these source codes that contains the files, that contains the functions. Okay, I'm just typing the command present working directory pwd. That's going to show me where I am currently. I'm currently under c_test, and typing the command ls from the command prompt is going to give me the details of the current directory, what are the contents of the current directory, and there are three elements. As you can see that if I am within c_test, just match the GUI graphical user interface with the GUI command user interface. Here you can see that there are three things, utils, headers, and client.c. As well, here it is utils, headers, and client.c. Okay, so now I need to go inside the utils folder. For that, I just need to type in the command cd change directory to utils, and I'm right now inside utils folder. So just type present working directory pwd, and it shows me that yes, I am within the utils folder. So I'm just double clicking here as well. That's not required. I'm just going to show you that it's really creating some files here. It will be visible in this window as well, what I'm doing through this command prompt. Okay. So first of all, what we need to do is to compile the source code in order to build the object files, and for that the command is gcc and then -c star.c. Now this star.c tells GCC to compile all the files with extension C, and just press enter. Now you can see that it has created two .o files, mymath.o and area.o, in the same folder. Now these two files are actually the object files, the compiled files against these two source codes. They are binary files and they are not going to be understandable by us if I try to open it in Notepad or text editor. Okay, now we need to build the library by putting all these object files into a archive, library archive. For that the command is AR for archiving and creating the library, and then give -c, then V, then Q. -c just to create the library in silent mode, silently. -v means it's verbose mode, and Q means quickly creation. That means if the library is already available, just override that without asking anything else. Okay, then -cvq, and then write the name for the library. Any library name should start with actually lib, and then I'm giving my library name, say xutils, and then .a. That's the extension for the library archive that we are going to create with AR. Now we need to put all the .o files within that library. So for that, just type star.o. Now that's going to put all the .o files in the current directory to the library named libxutils.a. Okay, pressing enter and see what happens. Here we have this libxutils.a created, and you can just get them here as well, and you can see that here it's saying that yes, indeed it has put all those .o files within the library. I'm just typing the ls command in order to display the content of the current directory. Yes, it is there, libxutils.a, as it is here. The same folder is displayed here, and here we can get the same folder by just typing ls command. Okay, so the library is created. libutils.a is the library. Now this is the distributable library that you are going to distribute to the other programmers, or you can use this library in some other program that is written by yourself as well to use those functions, get simple interest, get circle area, or get triangle area. Okay, I'm just copying it and I'm just pasting it here. Okay, so it's in the same folder with the client.c. It doesn't require actually. You can keep your library anywhere of your file system. I'm just trying to make it simple. Okay, along with the library, what else you need is the header declarations, the header files that is already given here in the header folder. Now I'm going to show you the client file. Client.c is going to utilize or call the library functions that we have included here in libxutils.a. I'm just opening this in Notepad again. Okay, so here is the program that is actually calling the simple interest, get simple interest function, and then I'm also calling the get triangle area, get circle area, all the functions that I have included in the library. And now what we need to do is to include the header files, otherwise compiler will generate warning and then error for all these callings, because compiler doesn't understand what these functions are actually. So we need to declare the functions. We can go on and declare the functions directly by writing the signature here. That would be inconvenient because you cannot force the other programmer to write the declaration every time they use the function. So that's why the headers are there. We have included the declaration in the header files, and the simple task is to include the header file here in your program so that the compiler is going to include them on behalf of yourself. Now, if you are including a header that is belonging to the default library of your language, that means of C language, then you should use this less than greater than sign. Now this is going to, in that case, the compiler is going to search for the header file in the include folder of your compiler installation. There is a folder within the distribution that is called the include folder, and that actually contains all the library header declarations. Now if we are using stdio.h, we need to include stdio.h, then we will just use these angle brackets. Then in that case the compiler is going to search for stdio.h first of all in that include folder of the system. Okay, now we don't have our header in there in the include folder. We have it here in the headers folder. So I'm giving headers slash the header name, area.h and mymath.h. So here header slash area.h, we need to mention the total path here so that the compiler can find it, and this should be within double quotes, headers slash mymath.h. So we have included both the custom headers that we have written for our own library, and we have called the functions here, and the library has been built, and that is this. So just save this file, and now I'm going to compile this file and execute this file using this library libutils.a. For that I'm going to the terminal once more. Now we have this. Okay, so I am right now within utils. So I am getting back to the parent directory, that's actually c_test, where I have kept the client.c. So you can see that here it is client.c. cd ... will take you to the immediate parent directory. Okay, so I am right now in c_test, and we have this client.c here, and we have that library.a here as well, and we have included the header definitions, and the header files are kept in this headers folder. So in order to compile our source code, the command will be gcc as usual, and then we need to provide -o. I'm asking the compiler that I'm giving the output file name by myself, that's why it's -o flag, and I'm giving, say, client, that's the object file that's going to be created by the compiler on compilation of client.c. And then comes the source file client.c that I intend to compile, and then what I need to provide is the name of the library file, that's libutils.a. that's our library, that's the total command, and I'm pressing enter. Okay, it's done, no error. You can see that client, this object file has been generated. So here it is, client, it's generated here. Okay, so now we need to execute that. So for execution /client, and you can see that it's running. So we have created our own library, and we have used that library from a client program. Thank you.